Open any real Magento page and the block tree you see was never written by one person in one file. The product page alone merges layout instructions from catalog, from checkout, from review, from CMS, and from your own theme, each contributed independently, each one only assuming the piece it owns actually exists. Today we open the real class that merges all of that together, the real two-phase pipeline that turns merged XML into live PHP objects, and the real recursive method that walks the finished tree and calls toHtml on every block. Every file and every line comes from a real git checkout of the pin 2.4.9 tag. Welcome back to Magento Development Deep Dive. Part 9 covered patches the classes that change a database once and remember they did it. Part 10 moves to the view layer, layout XML, the format every module uses to describe what a page contains, and the real machinery that turns dozens of separate layout files into one rendered response. We'll trace an actual layout file from catalog, the real merge class that combines it with everything else, and the exact two-step process, read then generate, that builds real block objects out of plain XML, using ground truth line numbers from a local checkout of the pin 2.4.9 tag. By the end of this part, 5 things should click. How dozens of independent layout XML files, contributed by completely different modules, get combined into one coherent structure for a single page request. What a real layout file actually looks like, using an actual shipped example with reference block, reference container, and container elements. Why building that structure happens in 2 separate phases instead of one pass. How the reader stage turns raw XML nodes into a scheduled, unresolved structure before a single PHP object is created. And how the generator stage turns that scheduled structure into real block instances, and how the final render walks the resulting tree. Strip away the code and every page goes through 5 stages. Declare, modules and themes ship plain XML files under a layout folder, each one using elements like block, reference block, and container to add to or adjust a page. Merge, the real merge class collects every file relevant to the current page's handles and combines them into one XML document. Read, a pool of reader classes walks that merged document and records what should exist, in a scheduled structure, without creating a single object yet. Generate, a pool of generator classes walks that scheduled structure and this time actually instantiates real block objects, setting each one's layout. And render, one recursive method walks the finished tree from the root container down, calling toHtml on every block it finds displayable. A few things help before we dig in. Part 6, on service contracts, is useful background. The blocks that layout XML instantiates are often the exact classes that call the repository interfaces we covered there to fetch data. Either a real Magento 2.4.9 checkout, or the GitHub tag open in a browser tab, so you can follow along in the real files. Basic familiarity with XML and how PHP instantiates classes from a string class name is enough. No prior frontend or knockout.js experience is needed at all. This part stays entirely server-side, right up to the final HTML string. This is real, unedited XML from catalog's product view layout file. Reference block reaches into a block that some other file already declared and adds a child to it, without redeclaring the parent. Reference container does the same for a container. Here it's reaching into the page's shared content container to insert a brand new product info main container, positioned before another sibling using the before attribute. Notice neither reference block nor reference container creates head.components or content. Those were declared elsewhere, most likely in a base page layout file, and this file only extends them. This is the real load method on the merge class, and it's the entry point for everything we're covering today. A page's current handles things like catalog_product_view, plus its specific product and category handles get added, then load first checks a real cache entry keyed on those exact handles. Only on a cache miss does it loop over every handle and call the real_merge method for each one, before serializing the whole combined result back out as a string and caching it. This is why editing a layout XML file and not seeing the change usually means a layout cache flush, not a code bug. This is the real, complete_merge method for a single handle. It marks the handle as currently processing, pulls in every package XML file that declares updates for it, then pulls in any database stored layout updates for the same handle, and only then marks it fully processed. That processing versus process state is what the else if branch checks if _merge somehow gets called again for a handle that's still mid-processing. That's a real cyclic dependency, and in developer mode it gets logged instead of recursing forever. This is the real generateElements method, and it's the exact boundary between the 2 phases in our diagram. First, reader pool interpret walks the fully merged XML tree and populates a scheduled structure pure data, no PHP objects yet, and it's this intermediate result that gets cached separately from the merged XML string. Second, and only after that's done, generator pool process walks the scheduled structure and this time actually builds real objects. Two pools, two passes, deliberately kept separate, which is exactly why a reader class and a generator class exist for every element type, block included. This is the real interpret method on the block reader, one of several reader classes the reader pool dispatches to based on each XML node's tag name. A plain block node calls schedule block, a reference block node calls a separate schedule reference method, and either way the result only ever gets written into the scheduled structure object, never a real block instance. Schedule block itself, right below this, resolves the element's final name, merges its attributes, and evaluates its constructor arguments, all still as plain array data sitting in that scheduled structure, waiting for phase 2. This is the real process method on the block generator, and it's phase 2 actually happening. It loops the scheduled structure exactly once to instantiate every block and register it on the layout object, and only in a second, separate loop does it call setLayout on each one that's deliberate, because setLayout is what triggers a block's own _prepareLayout method, and a block's prepareLayout is allowed to reference sibling blocks by name, which only works if every sibling was already instantiated in that first loop. Order here isn't an accident. This is the real createBlock and getBlockInstance pair, and it's the answer to a question every Magento developer eventually asks: where does the class attribute in a block element actually turn into an object? Right here. GetBlockInstance takes the class name as a plain string and hands it to a block factory, which goes through the object manager, honoring every preference and constructor argument from di.xml that we covered back in part 3. And the instance if check directly underneath is a real, enforced guarantee whatever comes back must extend abstract block or layout generation throws immediately rather than silently rendering nothing. This is the real rendering trio, and it's what actually produces the HTML you see. RenderElement is called once, from the template, on the root container's name, and _render container immediately calls renderElement again, recursively, for every one of that container's real children, whether those children are more containers or actual blocks. A block, once reached, hits _renderBlock, which does exactly one meaningful thing: call toHtml on it. Every nested container on a real page is the same method calling itself, walking the exact tree that merge, the reader, and the generator spent 5 stages building. A few things trip people up here. If you edit a layout XML file and nothing changes on the page, that's almost always a stale layout cache from merge, so load method caching the merged result, not a syntax error in your file. Flush the cache before you assume the XML is wrong. Reference block and reference container both fail silently if the name they're targeting was never declared by any other file. No error, the addition just never happens, which is a common source of quiet, hard to spot bugs. The before and after attributes only reorder siblings that already exist under the same parent. They can't invent a sibling to sit next to. And a block's _prepareLayout method can safely assume its siblings already exist, specifically because generator's process method calls setLayout in a second, separate loop, after every block in that pass is already instantiated. Let's pull this back together. Layout XML files use block, reference container, and container elements to build up a page declaratively, with reference elements letting completely independent modules extend structure they didn't declare. Merged real load method combines every file relevant to the page's current handles, and caches the merged result so this expensive step doesn't repeat on every request. generateElements runs 2 genuinely separate phases. Reader pool first turns XML into a scheduled structure, generator pool only then turns that into real objects. Generator block's process method instantiates every scheduled block before calling setLayout on any of them, which is what makes safe sibling references possible. And renderElement is one recursive method, calling itself through every container, that ends every single path with a real block's toHtml call. That's the real machinery behind Magento's layout XML, straight from a git checkout of the pin 2.4.9 source, every file and line verified against that exact commit. Part 11 stays in the view layer and goes one level deeper. Blocks and templates, what abstract block actually is, and how a PHTML file gets the data a block prepared for it. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in part 11.